Well, I usually start these webinars off with a reference to some obscure holiday. And while I could mention International Ninja Day, I wanted to take a more serious tone. Our hearts go out to all those affected by the recent wildfires throughout the state of California. I've spent a lot of time out there myself, and the devastation to such a picturesque state is just horrible. As they think about rebuilding, it's my hope that they first think about redesigning to be as fire safe as possible. This certainly wasn't the first wildfire, and it won't be the last. And that's why today's topic is so important. We're going to talk about meeting fire codes with fire-rated cementitious coated panels for wall and roof sheathing applications. And we're going to look at those products in terms of their structural performance properties, assemblies, and common applications. Scott Johnson is our guest today. He's the Construction Services Manager for LP Building Products. Scott works on product development, testing, and provides technical assistance for LP's FlameBlock wall assemblies and applications. Scott is a licensed engineer, and he spent 15 years as a structural engineering consultant in the Northwest prior to joining LP in 2016. If you would like to submit questions for our guest, and I hope you do, simply use the questions box in the control panel that is most likely located on the right side of your screen. I'll review those questions and pose them to Scott during the Q&A time set aside after his presentation. Scott, take it away.
All right, thank you, Mike. So today we're going to talk about fire-rated cementitious coated OSB, or FlameBlock is the product name. And we'll just kind of give you a pretty good overview of what it is, and hopefully you can take away something from today's presentation. So the summary, I think, just to reiterate, we'll kind of talk about what it is, how it's made, testing standards that are relevant to it, and wall assemblies and common applications where FlameBlock is used. With that said, this is kind of geared off of a spin-off of a AIA presentation where there's objectives. So again, I think I've already said it. We'll talk about what FlameBlock is. And kind of the key thing is how you can use it to meet your fire and structural performance in one sheet compared to a two-sheet approach and the associated savings with that. And then testing standards and code standards relevant to FlameBlock sheathing. And then usually at the end, we'll kind of go over applications. And I kind of put some other things in here towards the end that are just some common questions that get asked. So what is FlameBlock sheathing? It's a panel that consists of a proprietary magnesium oxide compound that gets applied to the sheet. The sheet is the coating is a non-combustible coating. However, the sheet itself is still considered a combustible element. There's a fiberglass mesh that gets put in this coating, and it's applied in a slurry to the sheet. And that fiberglass mesh is kind of dual purpose. One, since it's a cementitious product, it's prone to being brittle and shipping off, so that fiber mesh or the fiberglass acts as a reinforcing to help minimize the potential for pieces getting spalled off or chipped off. The other thing that's kind of interesting is when this gets exposed to heat, or the panel is exposed to heat on the coated side, it'll actually separate a little bit from the OSB backing, and it still stays nailed off to the studs, and it creates like this steam layer that starts billowing out steam as one way, kind of its one of its fire resistance properties. The coating, it's called pyrrhotite. The magnesium oxide compound, which is a natural occurring element, which is kind of like your Tums, includes like a magnesium oxide to it. Important question that is commonly asked is the OSB substrate chemically treated? And the answer to that is it is not chemically treated. This coating is applied to a raw sheet or an APA rated sheet of OSB, and the coating can be applied on one side or two sides, and it just depends on the applications of where one-sided FlameBlock or two-sided FlameBlock is required. Sometimes there's a perception that one-sided FlameBlock is 1 hour rated, two-sided FlameBlock is 2 hour rated. That is not an accurate statement. When we're looking at rated wall assemblies that utilize FlameBlock, it comes down to the assembly. All the components put together provide that 1 hour or 2 hour resistance. FlameBlock comes in standard 4-foot wide panels, and 8, 9, and 10-foot lengths are the standard lengths that are produced, or standard sizes that are produced. You can get sheets up to 24 feet long, but that is commonly going to be a special order product and would not be readily available. And the common thicknesses FlameBlock comes in is 7/16 all the way up to 30 seconds. If you look at the 7/16 and the 15/32 FlameBlock, it's actually made with the next thickness down of substrate, of OSB substrate. And the coating's about a 1/16 of an inch, so it will add to that thickness and you get that 15/32. So for instance, 15/32 FlameBlock is actually made with 7/16 OSB substrate plus the coating, but it is a 15/32 rated sheet. When you get to 19/32, it's actually the 19/32 OSB substrate plus the coating, and it's a rated as a 19/32 sheet. The nice thing with like the 19/32, you know, if this was like a type 5 type of project, you know, like a 3-story, 4 stories of wood framing over like a podium, a lot of times they're not necessarily putting shear walls on the outside, or at least in the Northwest. It's not a common practice. And so they'll just typically have 5/8 type exterior gypsum out there. However, the engineer may require that they have to have a shear wall pier. And so to avoid adding an additional panel to the outside of the wall or the exterior of the wall and creating 2 different assemblies that have 2 different thicknesses, if you were to go with like the 19/32 one-sided FlameBlock, it would still maintain that uniform wall thickness because it's roughly 5/8 of an inch. Same scenario with a type 3 project, the 15/32 when it's coated on 2 sides, which is common. It's coated on 2 sides, it's going to be a little under 5/8 of an inch. So again, it keeps that uniform thickness. And we'll kind of cover 2-sided and 1-sided, but for type 3 construction exterior walls, you're going to be using the 2-sided FlameBlock. And then all 2-sided products in 7/16 and 15/32 automatically attain Struck 1 design values. And then the weights of the sheets. If you look at just like a raw OSB or plywood, it's in the ballpark of 1.5 pounds per square foot. OSB is just a little bit heavier than plywood. That coating is about 0.6 pounds per square foot. And if you had a 1-sided sheet of FlameBlock of 15/32, that's about 2.1 pounds per square foot. Again, if you coat it on both sides and you're good with math, that gives you 2.7 pounds per square foot. And just kind of as a comparison, 5/8 type X gyp is about 2.5 pounds per square foot. So when you look at a traditional approach for a fire-rated wall where you have your sheathing and your 5/8 type X gypsum, you know, you're in the ballpark of 4 pounds per square foot. So there is a reduction in the weight of that wall assembly when looking at FlameBlock wall assemblies. Installation consideration. What I like to say is there are no special installation considerations. You don't have to use galvanized or stainless steel fasteners. Conversely, if it's required that your fasteners be galvanized or stainless, because maybe you have fire-treated studs or you have pressure-treated sill plates, you can use galvanized or stainless fasteners. You're still going to gap the panels. Like if it was raw plywood or raw OSB, there's that nominal 1/8 of an inch gap in between to allow for that movement as the moisture content in the panel changes. Typically, most assemblies with FlameBlock are not going to require a fire caulk. There are some that do, but probably the most predominant ones you would see in your market do not require a fire caulk. Sometimes as a way to fix things, if a piece of the coating gets chipped off or their panel joints are a little bit larger than what someone might be comfortable with, we would recommend just filling it with a fire caulk. And then as far as handling and safety requirements, you know, you're going to treat or you're going to use the same kind of protection if you were dealing with raw wood. Since the magnesium oxide compound is a natural occurring element in the coating, to my knowledge, there's no special disposal requirements when getting rid of the waste from a job site. A lot of times people ask, what are the design values? What are the shear values? And what we do is we just reference them to ICC ESR 1365, which basically kind of defines the criteria for how FlameBlock can be used. If you're looking at wall assemblies, the wall assemblies will be listed in there and how they're constructed. If there's load, they'll tell you what the axial loads to use for design are in the ESR. As far as shear values, the shear values are not in the ESR since it's a rated sheet of OSB with the coating on it. You go to the special design provisions for wind and seismic, and those are the design shears that are used. There's no special design shears currently published. The other thing I wanted to mention about the ESR, a common question I get is, do I have to use galvanized nails? It doesn't tell me in the ESR that I have to use galvanized nails or stainless nails. And what I tell them is usually the ESR is going to list restrictions. If it said you had to use, if it was required that you had to use galvanized or stainless nails, it would be specifically noted in the ESR that the treated fasteners are required. And again, here's the design manuals or the design codes that are used when working with FlameBlock, and it's the same if it was untreated wood, the NDS for wood construction, and the special design provisions for wind and seismic. These are the documents that are referenced in the ESR, or reference that you use these documents in your design. The structural performance, and kind of just to reiterate, the FlameBlock panel starts with an APA rated sheet, and again, the coating is applied to one or two sides. Once you physically chemically treat or coat an APA rated sheet of panel, it automatically nullifies that grading stamp, and again, you have to get it reevaluated. So when the slurry is applied or the coating is applied to the panel, they put it over the initial APA stamp, it gets reevaluated, and the new stamp is placed on the FlameBlock coating. The top, it says the fiberglass reinforcement increases strength, bending, stiffness, shear capacity, impact resistance of the panels. What I could say is unofficially yes, officially no. Really what that means is you are not taking any reduction. The panel is not chemically treated. The coating does not affect the OSB backing. Therefore, you don't have to take any reductions. If you're looking at chemically treated wood, whoever the manufacturer is for that chemically treated wood, they will list out what their reductions are based on whether it's bending, shear, the stiffness. So to my knowledge, most chemical products, chemically treated wood, have reductions associated with it. The coating causes no initial or long-term loss of structural performance, nor does it increase the water absorption of the panel. The sheet is still has permeable characteristics. It will take longer for moisture or vapor to work its way in. With that said, it will take a little bit longer for it to dry out. When I talk with contractors on job sites, especially with the two-sided FlameBlock, I say, make sure you give yourself just a little more time for that to dry out before you start putting the insulation in the wall and closing it up. And again, the structural design values are the same as for those wood structural panels in the same thickness category. Again, 15/30 FlameBlock is made with 7/16 OSB backing plus the coating, and it will be stamped as a rated 15/30 sheet. Two of the main code requirements required when you're looking at fire resistant construction is fire resistance and flame spread, and they kind of, how they sound is what they mean. Fire resistance is the ability of a material, or more commonly what we're dealing with are an assembly of materials, and its ability to withstand extreme temperatures on one side and acting as a thermal barrier and obviously not burning through. And this is done typically under a standardized set of conditions. And then flame spread is the rate of travel of a flame across the surface, again, under a standardized set of conditions. So the first one we're going to talk about is flame spread testing. It's often referred to, or its trade name is called the tunnel test. The ASTM designation is E84, and you might see this in the code somewhere. And this is the same thing if we're talking wood or if we're talking windows or doors. This is where they determine the flame spread rating. There's 3 different ratings, A, B, and C. And if you think of grades in school, A is good, B, and C down the line. So for a material to have a Class A flame spread rating, it has to have an index of 0 or 25, or 0 to 25 in a standard 10-minute test. And then Class B would be 26 to 75, and then Class C is 76 and above. And really those numbers don't mean anything. They're just an index or a kind of a comparison to the red oak. Red oak is what they use to calibrate their oven. So before they start a test, they'll run it with red oak, assign it an index, and everything else is a relative scale to that red oak. On a side note, they're actually changing the material to a different one instead of red oak. I think just probably more for a consistent measure. Now for wood to be considered FRT or fire retardant treated per the code, you have to extend that test for a full 30 minutes, and the flame cannot progress more than 10.5 feet. In this test, they don't measure burn-through resistance. Just because you think you can put a piece of tinfoil up there, it has probably a pretty good flame spread rating, but very little burn-through resistance. And in this test, they also measure smoke development. There's a criteria on how much smoke can come off of or how much burning and smoke. There's a limit to how much there's a limit to that, sorry. So criteria for wood, for fire retardant treated wood per IBC section 2303.2, again, just to reiterate, you have to get the index of 25, flame spread index of 25 or less in the standard 10-minute test. And again, you extend this out for a full 30 minutes and the flame cannot progress more than 10.5 feet. And then you have to satisfy the smoke development criteria. And then each sheet of FlameBlock is stamped, including in that grading stamp, that says it satisfies these 3 conditions. Burn-through resistance. So, oops. This is actually kind of an interesting test. So it's the ASTM E119 that's used for determining or testing your wall assemblies. And what you do is you build a mock-up wall. It's a 10-foot by 10-foot wall, and it becomes one side of this oven. And the photo on the top left, you can see as they're getting ready to start a test. They light the burners. You take your wall assembly, you slide it in, they clamp it off, and then they start the test. As soon as that thing closes off, they turn the temperature up. And you can see the photo on the bottom left. At the bottom, you see some orange cylinders, and those are hydraulic rams. And what they're doing is actually applying an axial load to the wall. And then there's little squares that look like some wires hanging off of them, and those are thermocouples. And so thermocouples are a fancy word for a thermometer. And so they're measuring the temperaturizing, that temperature gradient on the opposite side of the wall from where the fire, on the fire side. To pass this test, obviously, you can't have burn through. You can't see flames coming through the other side. The other criteria is it cannot get hot enough on that side of the wall or the opposite side of the wall from the fire that it could ignite wood or a cotton swab. So you're measuring the temperature of those. And so the average those cannot exceed 250 degrees plus your starting temperature. And then neither one, if one of them exceeds 325 plus your starting temperature, that would constitute failure of the test. The other thing they monitor is this wall for out of plane. You know, is the later stages of the test. You know, even though it's not burning through, your studs are hot enough that they're starting to char. You're starting to lose some capacity, and it will start to bow out. So they monitor that during the test. When they start this test, they heat it up hot and fast. So within a couple of minutes, you're up to 1,000 degrees Fahrenheit, about an hour into it, you're at 1600 degrees, and it will gradually increase for the duration of the test. The interesting, I went to a presentation and they showed a small mock-up test where they took like what would be a hotel room about that size, and they packed it with furniture from ceiling or from the floor to the ceiling, lit it on fire, and measured the temperature. So within like the first 5 minutes, 10 minutes, it's just gradually decreasing. And about the 6th minute, it takes off. And it jumps up to about 1500 degrees, and it burned that hot for about 15 minutes, and then it started to drop off because it ran out of fuel. So when you think of these hotels or apartments or condos where you have these 1 hour boxes, it's pretty amazing the resiliency of those wall assemblies. The other thing I like to point out is the different insulation types. So fiberglass insulation has a melting temperature of in the 1300 to 1400 degree range. And later stages of the test, if you're doing a 1 hour test or a 2 hour test, is that the insulation will melt and sloughs off and falls down into the cavity. And once that happens, you've lost your ability for the insulation to insulate the sides of the stud. And now you're having this burning or this charring effect that's occurring on all three sides once the flame's allowed to start propagating inside the cavity. Mineral wool, on the other hand, melting temperatures above 2200 degrees. So during one of these tests, mineral wool will stay in place and it will insulate the sides of the studs, and the charring is limited to the end. So it's almost like it's a controlled char of your stud. Just the inside or the end of the stud that's facing the fire side will see burning or charring. So that first picture, the picture on the top left, was right after the 2 hour test. And what you're looking at is 2 layers of 5/8 type X gyp that was inside the stud, or excuse me, inside the oven. It had fiberglass insulation and then 1 sheet of FlameBlock on the opposite side. So you could see, I always find it interesting, is the gyp broke down at the studs, and the charring that occurred on the studs, you can see that they were burning. Now, if you pass the E119 test or the fire resistance test, the next thing you have to do is a hose spring test, where you hit it with a fire hose from a standard distance, standard pressure for a standard amount of time, and that wall cannot break down. You basically can't have water coming through the other side, and that's kind of more of an integrity test of the wall in the event there was a fire, and the fire department comes out. The last thing you want is that thing getting lose its ability to support its load and have a potential collapse mechanism in place. And then the photo on the bottom of the bottom center is after the full 2 hour test, and you can see that the studs charred away, and the charring, that's where the 2 layers of 5/8 type X gyp was. So the charring happened to the studs, you lost in that cross-sectional area. And then that gray, white coating you see there is the FlameBlock coating, the pyrotite. So once it's seen enough heat and it's crystallized, lost its ability to off-gas moisture or H2O, it will start to crystallize and it turns that gray color. This slide is just a small scale test where there was fire-treated studs and fire-treated plywood with just a nominal fiberglass insulation. And this slide kind of shows you the importance of the insulation, how it's key. In the hour and 40-minute mark, you could see that it started to burn through the plywood. So the insulation obviously, lost, it got hot enough that it melted down and that flame was allowed to propagate inside the cavity. So looking at assemblies, or when you're putting assemblies in drawings, if you're an architect and you have the insulation, it's a requirement. It's important to make sure that you're using the right insulation associated with the assembly if the assembly is requiring specific insulation. And usually it comes down to density. The types of construction and FlameBlock sheathing. If you want to use it in type 1 and type 2 construction, you're typically going to be limited to non-bearing conditions. If you are using it in type 1 or 2 construction, you'll want to use the two-sided FlameBlock product that's required, or it's noted to say fire treated wood in accordance with 2303.2. Type 3, you're going to use it. You could use it at your exterior walls for 2-hour assemblies or less, interior assemblies, and then if you're using it on the exterior walls, it has to be two-sided. Type 4 construction, wall assemblies 2 hours or less, and again, you're going to use two-sided FlameBlock there. And then type 5 constructions, there's really no restrictions on where it can be used. Obviously, you can use it in residential construction. Now, I kind of wanted to go over some of the FlameBlock assemblies and its applications. So the first one, if we're looking at type 5 and type 3 1-hour walls, or type 3 exterior non-bearing walls, where you have a 1-hour resistance that is required. You could use the UL U348 assembly, which is a 1-hour assembly that has resistance from the inside only. If you had brick veneer or stucco, as noted in table 722 in the IBC, you can get 1-hour resistance with 7/8 inch 3-coat or brick veneer, basically a 4-inch nominal brick. You could have a symmetric 1-hour resistance where you have fire separation distances that are less than 10 feet. Where these assemblies, one of the advantages of this FlameBlock assemblies is that you can eliminate an exterior layer of gypsum. And a nice thing when you have, if this is 2x6 construction, you can maintain a consistent wall assembly. So maybe you can save money on door jambs or any kind of special windows. And if you're going to use 348 in type 3 exterior walls, you have to have the coating on 2 sides. And so here's just a schematic of the drawing. The 5/8 type X jip on the inside, 2x4 studs at 16, or you could do 2x6 at 24, or steel studs. Pretty much any insulation type is allowed. And then this would be one-sided FlameBlock, and the coated side is facing the stud. Since this is only an interior rated assembly, or only has fire resistance on the interior, the cladding is optional. And then the next assembly, or the 1-hour assembly, for FlameBlock is an Intertech listing, LPP/WPPS-6001. And so this is a 1-hour symmetric wall assembly, probably the most versatile assembly LP has. It does require 2x6 studs at 16 inches on center, because that's how it was tested. If you wish to go to 24 inches on center, we have engineering evaluation that supports that. This one utilizes a mineral wool insulation, and again, the mineral wool is there to have that controlled charring of the stud, so it's not allowed to propagate on 3 sides, and still maintain you don't lose the cross-sectional area as quick. Claddings, most cladding types you can put on there, steel siding, stucco, stone veneer. The only cladding that's not commonly used that's not listed would be vinyl. However, this listing has just been updated that if you use a 19/32 FlameBlock panel, the cladding is an optional component. It's not required. It's not required to attain that exterior fire resistance. And then with that said, that opens it up for claddings, for use of claddings not listed in the assembly that can be used. Where this one has its greatest, or where this one assembly is commonly used, is going to be, your residential construction when you're encroaching a property line or an adjacent property. Type 5 exterior bearing walls, 2 1-hour walls back to back in a townhome application. Again, to avoid having to use a cladding or put a cladding on there, you would want to use the 19/32 FlameBlock. And then 2 1-hour walls in back-to-back type 5, for 2 1-hour walls in type 5 construction for firewalls. in lieu of a 2-hour firewall that you commonly see with shaft wall or CMU. Now, this is, from what I've seen, a lot of times when people are going to do these double walls back to back in Type 5 firewall, they're doing a 2-hour wall. There's a section in 706.2 of the IBC that if you build and construct your wall in accordance with NFPA 221, essentially you can get away with 2 1-hour walls back to back. And if you think about this, you know, when you're jointing the building in a Type 5 project, you know, you're trying to keep the square footage down, and you're creating independent structures. So if you think that those were actually 2 independent Type 5 buildings that were 6 inches apart, you're only required to have 1-hour resistance on both of those walls. And that's essentially what NFPA 221 is telling you can do, or allowing you to do. And if you look into the code commentary on this section, you know, and read through it, it's kind of geared towards, that 2-hour requirement is kind of geared towards a fire barrier almost, where you put the shaft wall and that shaft wall, or a CMU wall, and that is your fire barrier. If you're going to use this assembly in Type 1, Type 2, Type 3, or Type 4 construction for exterior walls, it has to be 2-sided. Oops. And just kind of a comparison, you know, a common 1-hour assembly is the U305, and that one is 5/8 Type X gypsum, each side of the wall, studs, and then if this is going to be used like in Type 3, you're going to have fire-treated wood or fire-treated plywood included in there, and you can always add plywood or OSB to a UL assembly, and that's allowed in their standard language, or the ANSI 263 document. And you compare it to the Intertech listing, where you just have FlameBlock and gypsum. Those are your 2 panels on the wall. So you're saving not having to put up an additional layer of gypsum, and your wall assembly is going to be a little bit thinner compared to a traditional approach. This assembly also offers some flexibility when this might be used like a retrofit. You might have had something that was built 40 years ago, 50 years ago, and they used 2x4 construction, and you know, maybe they had some dry rot, they have to replace some of the sheathing, but now they're mandated that has to become a 1-hour wall. One way you can demonstrate the exterior 1-hour resistance is through a calculated method. So going to the IBC section 722.6, the code assigns 20 minutes for 2x4 studs. Well, it says 2x studs at 16 inches on center. It doesn't distinguish on what size is required. Table 722.65 gives you 15 minutes for installation that satisfies the criteria in that section. Basically, a high-density cellulose or a mineral wool installation. FlameBlock has a 20-minute thermal barrier with 15-30 seconds flame block, and then you just have to get 5 minutes of a cladding from your exterior cladding to get a full 60 minutes. And just as a frame of reference, you know, 3/8 wood structural panel made with exterior glue is assigned 5 minutes per table 722.6.21. And that's a good way to kind of calculate the fire resistance if it had 2x4, since the Intertech listing was tested with 2x6 and requires 2x6 if you're going to reference that assembly. Type 3 and Type 5 exterior bearing walls for 2-hour construction. Kind of the bread and butter FlameBlock assembly is the UL U349. So this is constructed with 2 layers of 5/8 Type X gypsum on the inside, 2x4 studs at 16, or you can go to 2x6 at 24, and steel studs at 24 inches on center. This requires a nominal fiberglass insulation it's not listed up there, with a density requirement is 0.25 pounds per cubic foot. This was tested with 2-sided FlameBlock, so it requires 2-sided FlameBlock, and this assembly is rated for 2 hours from the inside only. Since it's rated from the interior only, the cladding is an optional component and not required as part of the fire resistance. And the bread and butter for this assembly would be Type 3 exterior bearing walls, or type 4 exterior non-bearing walls. And if you were to compare this assembly to a fire-treated wall assembly, for instance, the V314, they're very similar in their construction, but there are some nuances. You know, on the inside, you're both going to have 2 layers of 5/8 type X gypsum. The studs are going to be fire-treated in the 314. However, the 349 doesn't require fire-treated studs, but you are allowed to add fire-treated studs. And that's in that standard UL language. So if this was being used in type 3 exterior wall, you could use fire-treated studs. And then on the exterior side, you're either going to have a sheet of FlameBlock or a sheet of FRT plywood. Same amount of layers with both assemblies. Just some differences between the two would be the installation requirement. You know, make sure if you're going to use with these fire-treated wall assemblies, and the same thing with the FlameBlock one, is check the installation requirements and make sure that the right one is being used. Some wall assemblies, fire-treated wall assemblies, require mid-height blocking in the walls is another thing to look for. And then whether galvanized fasteners are required. Most fire-treated or chemically treated wood products are going to require a galvanized fastener. And then there are reductions associated with the fire-treated wood. For one thing with the FlameBlock, with the sheathing and the in-plane shear capacity, if you're using 7/16 FlameBlock, you're going to use 7/16 design shears. Whereas if it's a fire-treated product and you're using 15/32 fire-treated plywood, you're probably using design values of 7/16. And what that reduction is, or what thicknesses to use for design, would be referenced in their code approvals. Another FlameBlock 2-hour wall assembly is the W408. This assembly has a 2-hour interior and a 1-hour exterior rating. And the difference between this one and the 349 is the use of mineral wool insulation. It also requires two-sided FlameBlock, and an exterior cladding is required as part of the assembly. And so this one would be type 3 exterior bearing walls. Really what this assembly is a springboard into other assemblies. So if you were to add 3-coat stucco, 7/8 of an inch thick stucco, or you have a brick veneer on the outside, that will now make a symmetric 2-hour wall assembly. And these are supported by engineering evaluations. And again, kind of the benefit with this one would be is you're eliminating that exterior layer of gypsum that would be required with those types of assemblies. And then a new assembly, FlameBlock assembly, is the V337. So this assembly is a 2-hour symmetric rating, has fire resistance from both sides or either sides, and essentially it's the same thing as the 408, except there's a layer of exterior 5/8 type X gypsum. So this is a symmetric 2-hour wall assembly. And again, type 3 construction, exterior walls where you're up against fire separation distance less than 10 feet. This one also could be used where you have elevator or stair towers that are 2-hour, basically your 2-hour cores there. Different parts of the country, they do different things. I've seen CMU where they use CMU for their stair and elevator towers. This might be an option to consider because when you add the thicknesses up, this is 8 inches. So you're not necessarily adding any thickness, and it could be a potential VE item on a project. And then just a comparison of the V337 to a U301 assembly. The U301's 2 layers of 5/8 type X gyp on each side of the studs. If this is a shear wall, you're going to add a sheet of FRT plywood to this wall assembly. So you'd have 3 layers, three sheets on one side, 2 sheets on the other, compared to the V337, where you'd have 2 sheets on each side of the wall. I will note that the V337 does require mineral wool insulation, whereas the U301, there are no insulation requirements with that assembly. And the FlameBlock assembly would be obviously thinner because you're saving or eliminating one layer of 5/8 type X gypsum. And then there's obviously the time savings associated with not having to skin the building with another layer of 5/8 gypsum. If you were to look at costs, material costs and labor costs, really everything washes out. You know, if you're looking at pricing, FlameBlock usually is priced to what it's replacing. So a sheet of two-sided FlameBlock would be approximately equal in cost to a sheet of fire-treated plywood and a sheet of exterior gypsum. So those costs should wash out. Mineral wool isn't commonly used. It is used, but it's not as common as like an R21 fiberglass, or at least that's my market out here in the Northwest. So there is an additional square foot cost associated with the mineral wool. However, you take that additional square cost and compare it to your labor cost to install another layer of 5/8 type X gyp with the 301, that should wash out. And really material labor costs are going to be equal, and you're truly left with is the time savings. You know, if this is 5-story wood construction and you can knock a week off per floor, you know, maybe you save 4 weeks, the framer saves 4 weeks on the job site by not having to put up the gypsum. Vertical continuity of firewall. So when this first came out to the market, its application was in roof deck application. So the code says you have to have a 30-inch parapet that sticks up above the roof to be your barrier. However, in lieu of having a 30-inch parapet, you know, one option you can do is put some roof sheathing for 4 foot either side of the wall that is either FRT plywood. You could do FlameBlock there with the coated side facing down, or you could do gypsum. Basically anything that has a Class A flame spread rating can be used in this application. Very common to do, and obviously you can't have any openings or penetrations into the roof in that 4 foot zone. Townhome separations. So there's essentially 2 ways to do this. You could follow our, section 302.2.1 or 302.2.2. So the first one is where it's a double wall configuration, where you're building 2 one-hour walls back to back. I've seen this in California where townhomes are independent tax lots. So they're independent tax lots. So there is a property line running through the gap separating the townhomes. So each one of those walls would have to have a 1-hour rating. So what we propose for people to do is to use our Intertech listing LPP WPPS 6001 in a back-to-back configuration with 1932nd FlameBlock with the coated side facing out. Again, there's no cladding required if you use the 1932nd. And if you were doing this with like a 305 where you have 5/8 type X gyp on each side of the wall and you have to add a layer of sheathing, it can get a little cumbersome to do. So this actually really simplifies the construction. You could build a wall, nail your FlameBlock down, have it inspected, tip the walls up, and you're done. You don't have to get back into that gap. So definitely simplifies the construction and eliminates any special sequencing that may be required to bring in your trades out. And then in this approach, or when you're following the double wall application, to my knowledge, there's really no restrictions on what kind of utilities you can put in the wall cavity. The other application, or the other way you can do it, is a common wall, where you create a common 2-hour assembly. And the image you see down there is a shaft wall assembly, where a 2-hour assembly that's very commonly used in these townhome separations, where your barrier, or you have 2 layers of 1-inch gypsum inside the cavity. When you do this common wall approach, there's limitations on what you can put what kind of utilities you can put in the wall. Essentially, you're limited to electrical outlets. So FlameBlock's solution for this common 2-hour wall, 2-hour condition would be our U350 assembly, where it's essentially our U348 built back in a back-to-back configuration. You have 5/8 type X jip on the inside, a fiberglass insulation, 2x4 studs at 16, and then the one-sided FlameBlock with the coated side facing the stud, and then a 1-inch air gap. So the image on the left here is showing a resilient channel. That resilient channel is there for the sound only. It's not required for the fire performance or the fire protection. With that resilient channel, you're going to get an STC of 61. If you don't have that resilient channel, you're going to have an STC that's in the low 40s. And again, this would be an assembly in lieu of like your shaft wall assemblies like U336. And then there's always the hot topic that I come across a lot is the continuity. So if you read that section of the code, this is taken out of the 2018 IRC, it says that the fire resistance rating shall extend the full length of the wall or assembly, including wall extensions through and separating attached enclosed accessory structures. So a lot of jurisdictions I've come across have interpreted this to mean that the assembly itself cannot be broken and has to be continuous from the foundation to the roof. Our opinion at LPE and the opinion of independent wood agencies is you just have to demonstrate continuity. The assembly doesn't have to be maintained. And I like to, that photo on the left, or the image on the left, is a shaft wall assembly. And if you look, this is how it's shown in the UL assembly. It's showing studs each side of the 1-inch jip and half-inch interior gypsum. So that is part of the assembly. So when you frame a floor into the shaft wall assembly, or you frame a floor into the U350 assembly, you've technically broken that assembly. And what you need to do is maintain continuity, just to allow for construction to take place. And so how do you demonstrate that continuity with like FlameBlock, with the U350 assembly is we've done our own testing and have engineering evaluations that demonstrate the protection through there. If somebody wants something from an independent agency, you could go to the APA and they have a document or a form D350C that gives you prescriptive details for how you maintain that fire resistance through that floor. These assemblies shown in the APA document are based on calculation. To my knowledge, there is not any kind of ASTM or UL listings for floor-to-wall that determine a fire rating. It's demonstrated through small-scale testing or calculation. And then kind of hitting on the 2-hour firewalls and type construction where you're jointing the building. This is kind of a common wall assembly I've seen where they have 2 layers of jip on the, I guess you'd call it the living side, and then 1 layer of jip or plywood, 1 layer of jip on the cavity side. Essentially, that's creating a 2-hour interior, 1-hour exterior assembly. So I've seen this, but again, if you go into the NFPA 221, you can get away with 2 1-hour walls back to back. And if this was like a seismic joint or you're gapping the building, just how you construct this, if you had a 6-inch gap, how do you get in and put the gypsum on the inside or that interior space? If you read the language like in a UL assembly, you're supposed to offset the joints of the plywood and the gypsum. They can't be on the same stud. So if this wall was 200 feet long, you might have to build a 200-foot section of wall and tip it up. And going with like a FlameBlock assembly back to back, you could definitely facilitate construction if you're using this LPP WPPS 6001 assembly. Other applications where FlameBlock can be used is if you have these deck wrap projects where you're wrapping residential around a parking structure, whether it's type 3 or type 5 construction. If you look at kind of how this gets detailed out, you know, you'll have the concrete or CMU wall of the parking garage, and then a wood wall. Typically this is in the corridor. The corridor runs next to the parking structure. This is type 3. That's a 2-hour wall. What I suggest to people to do is try to get away with this as a non-bearing wall. That way you could use the Intertech listing 6001. That way you're only having one sheet on the gap side. If you needed a full 2-hour resistance, you could use the V337. And again, what simplifies, you know, if you can eliminate the amount of layers of gypsum on that cavity side, it will definitely help facilitate construction. And if you look at this detail, you know, you can see they put the sheathing on the interior side of the wall. You know, ideally, if they can put it on the gap side, it definitely makes things easier and doesn't require some special detailing. There are some tricks, I think, to get this to be considered non-bearing, even though it might be supporting a little bit of floor load. And if anybody's interested in that, feel free to reach out to me. And then the type 3 construction, the full floor-to-wall interface, I think this is starting to get some clarity now. Over the past few years, there's been the debate of, you know, at that floor space in the wall, is it required that has to be fire treated? You know, that's been a debate that was going on for a while. So in February of this year, the American Wood Council produced a document that is a good reference for these floor-to-wall connections in type 3 construction. The images you see on the screen kind of show approaches that have been done, but essentially they simplified it, or they're saying you don't have to put fire-treated wood in there, and it's based on calculating the char resistance of your rim and demonstrating that you have 1 hour or 2 hours through there. It just depends on whether your floor is an unprotected floor or a protected floor, or like type 3A versus type 3B. And then FlameBlock and weather barriers, like adhesive or fluid applied. You can put fluid applied or adhesive barriers on FlameBlock. And on the right there's an image of some companies that's products that have been tested and have been approved by the manufacturer to be used on the FlameBlock. If there's a WRB that is not on this list, or somebody wishes to use it, you would reach out to us. We would send samples to that manufacturer, and they would just validate that their product is compatible with our coating. Typically, products that are compatible with concrete or CMU would be used when it's applied to the coating. And then some questions that come up during construction is, what happens with overdriven nails? And overdriven nails does not generally affect the fire performance of the wall. You know, it's a few nail heads getting punched through is not going to significantly detract from the fire resistance, particularly if it's an interior rated only assembly. When this happens, I'll recommend to people to reference the APA document for overdriven fasteners. It's also a good idea to consult the engineer record just for make them aware of it, and also to seek their recommendation. The other question is excessive panel joints. You know, if they're putting the panels up and, you know, instead of having that nominal 1/8 inch gap, you know, maybe they're having a 1/4 inch or 3/8 of an inch. Typically, what LP would recommend is you caulk joints in excess of a 1/4 inch. Anything larger than that, you either put a piece, you know, cut a new strip out and put it in, or you could infill with gypsum. The other thing to do is when you have those excessive panel joints, you're have the potential that your fasteners, if this is a shear wall, do not have adequate edge distance. And so this is something that should be consulted with the engineer of record. And again, if you're looking at an interior rated wall, the panel joints of the FlameBlock on the opposite side aren't as critical. If you're looking at panel wall assemblies, FlameBlock wall assemblies with exposure from the exterior, and you have panel joints, again, part of the fire resistance of those assemblies is controlled charring of the studs. So when because you have that mineral wool that's still in place, so a gap, whether it's an 1/8 inch or a 1/4 inch, or maybe even up to 3/8 of an inch, is not going to detract from the fire performance of that wall assembly. But just as a general safe rule, cover all, anything in excess of 1/4 inch, we would say fire caulk it. And then also if a piece of coating gets chipped off or falls off one way, when people ask, what do, we would say, okay, just put a little fire caulk over it. And that is an intumescent fire caulk. Wildfire zones. So California, this is kind of geared towards California. So California building code accepts FlameBlock for use in these wildland urban interfaces. And it's actually, LP has gone out and done like our own testing. And actually when there's a fire event, we send people out, we go look at it. We try to figure out the cause of why things burn down. And what we're kind of finding when we go to meetings and hearings is that there's a knee-jerk reaction to ban wood. And people think of wood, they think wood is combustible, but a lot of times these fires, if it's a massive wildfire, there's really nothing you can do. But there are certain steps you can take when you're constructing, or like if you're building your home in one of these areas, just to help prevent a catastrophic burning of your house and like I'll call it a mild wildfire. Vents, having your stuff vented, using proper windows, proper doors. The cladding on the outside of your walls is just one component of it. If you're going to do exterior walls in the California wildfire zone, you can see in 708.3 there's some criteria for it. Essentially, you can use FlameBlock sheathing around the outside. If you skinned your building or your house with FlameBlock with the coated side facing out, and put any cladding that's listed in the Intertech listing, you can satisfy that exception 2 in 707A.3. Or you could follow wall assemblies that are noted in Note 5. And LP actually has a few wall assemblies where essentially you put FlameBlock as your wall sheathing, and you could put lap siding up, like a cedar lap. And then the same thing with eaves. You could just put you could use FlameBlock with the eave of the coated side facing down and exposed, and that's because it's a Class A flame spread rating on that product. Or you could also follow the criteria of the exterior portion of a rated wall assembly. And here, down below the CAL FIRE eave listings, you can see it for closed soffits. And then FlameBlock is an ignition-resistant material that can be used in open eave construction. With that said, are there any questions or comments?
Well, thank you very much, Scott. And yeah, you posed it to the audience exactly the way I would have. That if they've got any questions, please go ahead and send those in, because we will take them now. I do have a couple questions for you, and it's not on something that you hit on, I don't think, in your presentation at all, but it's certainly applicable. Do these types of products and applications make a homeowner eligible for any kind of insurance discounts?
Oh, that's a good question. To my knowledge, no. Not that I know of. I mean, that's something, though, actually I should look into.
Well, I mean, I opened talking about the wildfires in California. There's wildfires in other places too, but it's once those go through, the claims that are paid out and all the money that's spent, it seems like there may be an opportunity there. And it does lead me to my second question. Are there any jurisdictions, and I know we've got a lot of code officials attending this, are there any jurisdictions potentially or particularly in fire-prone areas that might be incentivizing these types of products via the permitting process, during the construction phase?
Again, that's a good question. I haven't heard of that, but it could be happening. I wish I had an answer for you.
No, it's okay. And part of it is, the insurance payouts, but I think the other part and why I ask about the jurisdictions is because of the incredible toll that these wildfires take on the first responders, on the firefighters. The incredible danger they put themselves in, the length of time that it takes to battle these fires. There's a cost associated with that, intangible, but also an actual fiscal cost. And mitigation on the front end would sure seem to potentially, anyway, reduce that cost in the event of a disaster.
Yeah, that's a great question, and I think there's a lot of people going round and round on how do we move forward with this, and wildfires. Well, the intent or kind of the hope is that a wildfire is coming. In the ideal world, it's coming. You have time to get out, so it's more of a property protection versus a life safety. And that's not always the case, but so as far as, it's not like a earthquake where the building can't collapse and it's, you're designing it for life safety so people can safely get out. With wildfires, it comes down to property protection. So the fire department theoretically doesn't have to go out and fight your fire, or it might take a while for them to get there because you're remote. So you want to try to build in a way to help minimize the damage in the event there was a wildfire. The other part of it is prevention. How can you, are there ways or things that can be done to help reduce the amount of these fires? Some of them are a lot of them are lightning. You can't stop Mother Nature, but what can we do for man-made ones? Like, the power grid. When you get the high winds, you shut the power grid down. People go without power just so those wires don't arc in a high wind. So there's a lot of things to be figured out with that. And then you have these massive fires where it creates its own weather pattern. And honestly, those, other than building concrete bunkers, it's hard to say how much effort do you put into building, or how much cost or how much added cost do you want to add to somebody building a home to make it fire resistant. There's kind of a balancing point there.
Well,
great question.
I'm glad you brought some of that up, though, because I certainly didn't intend to couch your presentation in a wildfire only context. Home fires, accidental fires, within a single family home, within a unit, are probably just as, if not more prevalent than anything from a natural disaster like a wildfire. So I'm glad that you brought that up. I didn't want that to get neglected. Give me just a second here. I am trying to, yes, we do have a question from Daniela, and I want to make sure I get to that too. So she's asking, based on your experience for a fire-prone area, would you use steel studs or wood studs plus a FlameBlock material for a single-family residence? And she's asking because she has a client that had their house burned during this last fire in Malibu.
Oh, well, me personally, wood studs. And if it was traditional approach and these studs are holding up your floors or your walls, if you think about kind of the mind experiment. If you're sitting around a campfire and you put a steel stud in the fire for 10 minutes, you put a 2x4 stud in the fire for 10 minutes, and then pull it out, and you can bend that steel stud, where the wood stud still has, it's not going to bend, it's not going to break. It's probably charred, but it still has structural integrity. And then the other part with steel, again, a lot of times people go back to wood burn. One thing people don't think about is heat conductors, conduction of heat. Like for instance, fiber cement, non-combustible, it doesn't burn, but what kind of heat transfer does it have through it? If you had like a metal siding on your wall, a metal cladding, it's not going to burn, but it's going to transfer the heat really, really quick. It's going to heat up and then get hot enough to ignite whatever is back behind it. So in my case, a wood versus steel, a steel stud, I would pick the wood.
Gotcha. Well, I don't see any other questions, Scott, so I certainly want to extend my gratitude for you for sharing your time with us today. I know we got into some very heavy material, but for the audience that we have, usually with code officials, builders attending, this is right on point with them. So I really appreciate it.
Hey, no problem. I appreciate the opportunity.
And I want to thank our audience for attending today. Thank you, Daniela, for your question. We've got one more webinar before the end of the year. And the good news is you don't have to wait too long for it. In just 6 days, we'll be talking about air sealing with Charlie Hack of NEMA. Make sure to join us next Tuesday at our usual start time of 2 p.m. Eastern Time. Until then, have a great rest of your week. Take care.